Hello, hello. Invalid Zoom cert. No, I did not. Oops. Welcome, welcome. So half of you here knew that the last class ran over. Which was interesting because I started the class with, I'm not sure what we're going to do today. And then we ran late. So, that's typical Carrie, I think.
Hey, that's better than the alternative. Like, I don't know what we're gonna do, and then like halfway through, you're like, well, let's just go work on other
Okay,
stuff.
we're done.
You know?
Yeah. Let me close up while we're getting ready here. While we're, I got all kinds of craziness going on. We were troubleshooting servers and playing with PowerShell, and it's kind of funny. We're doing do what?
Anita brought us snow.
Yes, it's snowing again. We don't need
You're
any.
welcome.
We don't need any more snow.
I know. I was kind of surprised, and my sister just came back in. She's like, "It's snowing." I'm like, "What?
No.
That's crazy."
Yes, I just got a new play toy, and I don't want it to be cold outside. So,
did the water breakage at the main campus mess with any of the servers?
So I don't know the exact story, but it sounds like the water pipe broke and flooded the server room, and then but they recovered pretty quickly. I mean, you think about it, like I know we had several students working on stuff, like it was 4 or 5 in the afternoon, and by 9-ish or so they were back up and running. I mean, they were back up and running within 4 hours, and the reason for that is the data center that is in the library, the SRC, right, the Student Resource Center, that data center is duplicated at the west side. So once they knew they had a problem, it was a matter of rerouting, right? Just changing DNS settings, right, to reroute everybody to the other location, and then utilizing the backup system. So I don't know what the exact damage was, but I mean, even if
that's what I was wondering, how they got it back up so quick. Because they still have fans on the server room and everything.
It's still. I'm pretty sure that room isn't functional, right?
Yeah,
it won't be functional for a while, because if it ruined, I mean, if the servers, I mean, if it was just a power got a problem, then we can replace power supplies and get back up and running. But if the servers got damaged, if they got water on them, then the servers are going to have to be replaced, because water and electricity don't work well together. So
there was definitely water. There was we took out probably I don't know, probably 30 or 40 computers and monitors and stuff. Yeah,
I'm glad that that our Nutanix system is over in Smith Brasher then. So they were able to reroute, because they have that entire data center is duplicated at the west side, which is really good planning. I mean, that's exactly what should have happened. Like, holy cow, right? This building is no longer usable. Like, this space is no longer usable, but we're back up and running 4 hours later. I mean, that's rather good, right? From a disaster recovery standpoint. Yeah, I don't, at this point, I think, glad we're not in Dallas. I don't think anywhere in Texas right now is really good. Like, as soon as this weather got over the top of this mountain and started going downhill, it got bad. So I think we had the kind of our normal, the weak side of the storms. I think the storms get significantly worse as they come down off of the mountains. So I don't know that we realize how lucky we are for our position, geographically as far as weather is concerned. From that standpoint, like we don't have the winds rushing down the slopes and causing tornadoes and a lot of the mixture of cold and hot air and all kinds of stuff that you get as you move away from us. So it got really cold though. So hopefully we didn't damage anything on the RV. So we'll see how that goes. But anyways, welcome to, like you see, I got to figure out which of these I need to be running right now. Disabling IP version 6, copying, let's close down servers. Servers, we don't need that one. That one we'll talk about in this class briefly. Let's get rid of that one. I don't need that. Don't need that. Welcome to prep, right? Seeing all my prep work. Server, libraries, networking, Zoom. All right, and let's just start over. So we get down to one home page. All right, cloud computing. So I am back in Albuquerque finally. So we were able to leave Las Cruces. We got all the seed in the ground. We got half of the fields watered. We got half the pecans harvested. We made arrangements to have the other stuff taken care of so we could take a break. 3 weeks is enough. I'm not a farmer. I don't want to be a farmer. I also don't want to be my in-laws' farm hand specifically. So, but we're back here. So this week I was able to get this class and my 1410 classes all caught up. Like all the grading was done earlier today. One thing I don't have in this class is I don't have the grades transferring from Cengage over here. So I've been watching your Cengage, and this class is doing really well from that standpoint. For the most part, everybody's caught up and has a good grade. In fact, I think our grade as a class is like in the mid 90s, which is really good. And that's one of the things I found out, that I find in this class. There's very few people that once they get here, I mean, there's actually interesting things to do, and you're learning a bunch of new stuff that you've probably never touched before. And things get done when that happens. So that's nice. So we're on to chapter 5, I believe. Let's take a look at where we're at on our schedule so that we are all on the same page. I did move the due dates from yesterday or from last Sunday to yesterday, right? So then that kind of blanked out last week as far as due dates were concerned. So if you got in there and you're like, what happened to all the due dates? They all moved to this week because they're on Tuesday instead of Sunday. But we're back on track at this point. So we are here in module 5. So cloud connectivity and troubleshooting. That's due this Sunday. And then next week, we're going to do some cloud practitioner stuff. So we'll talk about the actual AWS cloud practitioner certification.
Can I ask a quick question?
Yep.
Is the GCP, let's see, the one for last module, the GCP VPC setup, I guess, is that easier than the other ones?
I didn't do that one yet, but I'm pretty sure it is.
Okay. Yeah, it's easier.
GCP tends to be the easiest of all three.
Because this whole subnetting thing is where I get lost. I did the Azure and the AWS one yesterday, and I was like, okay, I have to just get after it because it was too. It's just intense. So
yeah, Azure was we did Azure on the video, and it was ridiculous. It was because the first couple of the steps are like, wait, these aren't the same place, and you got to figure out what's going on. And then they wanted you to add things, and then you're trying to. That was one of those ones where they're kind of I think a step too far for us. Like how are we supposed to know that that's that you can't add a third one without you telling me that you can't add a third network interface, right? So that was kind of
supposed to have prior knowledge of it or something. So
yeah, kind of a weird one. So that's why I like doing these labs together. But yeah, I think you'll find that GCP in probably 90% of all of this is going to be the easier fewer clicks, it's easier to get to the point where you need to be. It's easier to kind of track to it. Google's done a really good job from the organizational standpoint of that, right?
Right.
I think Amazon has taken the approach, we want to give you every single service that we could possibly think of, and then a whole bunch more that you will never know that you want until you discover them, right? And then you can't live without them, kind of a approach. So their approach is, I'm going to give you everything, and they're not real organized about how they do that. Like, even if you just go to the dashboard to try to find something, like sometimes it takes you half an hour just to find what you're trying to find, and then you're like, why is it named this? Like, I can't understand that that's what it's named, right? So you gotta understand their code and their way of thinking. Microsoft has taken the approach, like from a sysadmin standpoint approach, right? So if you're a system administrator, like that's more like their mindset, right? So they're doing what they're kind of doing is what you would normally do on-prem. They kind of duplicated that into the cloud, and some of that becomes clunky when they do it that way, right? Because cloud really presents this new way of doing this. Like, you can actually do some really cool things, because you're not restricted by a piece of equipment, right? But Microsoft kind of views it as if it was all pieces of equipment. So their approach is a little different. And then Google's approach is simplicity, right? So they kind of going for, how do we, give you the base level of services that you want and make it easy to find, make it easy to understand, make it easy to deploy. And then they, the underlying thing, which I think is really important about the GCP cloud, is that it's a global thing, right? You once you've got your thing set up, like, you can move around the globe really easily, all of your locations and things like that, and you can be real dynamic with it. So, but you'll find that theirs is the simplest of them all. AWS tends to be the most complex because of the volume of things, and Azure is complex because of the way they do things, right? So depending on how you look at it, some people will find Azure to be more complex, just because the way they've structured their the system, or you may find AWS to be the most complex because of the sheer volume of things that you can do. But yeah, I mean, each one of them there's some positives and negatives about each one of them. And the cool thing about this is you're learning all three, so you're not going to be bound by, I only learned AWS. I need to use AWS because that's the only thing I know, or I only know GCP, or I only know Azure. Like, you'll have a good baseline understanding of all three, and you can kind of pick and choose which ones work best for you. And we'll talk about, actually, that's kind of what today's talk is about, is like, hybrid cloud setups, like, on-prem with a cloud provider, or maybe even two cloud providers, and then sharing data between those, and a bunch of different scenarios that we can kind of work through today. But yeah, I think you'll find the GCP one to be simpler, right? Simpler than the other ones, right? So then Noah, is it a bug, or did you change? Also, you did find something where they could add a third interface on a VM that's not supposed to allow it. Okay, cool. Because we fixed, we were able to add a third if you wanted to beef up your server. That was one way to beef it up. Or, right, you stay with that and just don't do three, right? That's the other option that you have. Or you find Noah's bug and you add the third one anyway. Right? So good stuff. I love it. So with module 5, we'll be halfway through the material as far as Cengage is concerned. We're going to jump to looking at the AWS Cloud Practitioner exam next week. Then we'll get back into 3 modules, 6, 7, and 8, which is all going to deal with identity management and security. And then we'll talk about the GCP cloud. And then we'll finish up with how to do some management and automation on the cloud. And then we'll talk about the Azure Fundamentals certification. My honest opinion is if you go through the material you can probably spend, you know, an extra 20 hours covering kind of specific things with Cloud Practitioner, and you can sit and take that exam, right? That exam with our discount, which I still got to get arranged, is like $50. Okay, so it's normally $100 exam, so it's not an expensive exam, but it will give you a cloud certification, right? So that's going to separate you from every other entry level, you know, network engineer, network certificate, you know, system engineer, because you'll have a certification. I think same thing applies with GCP. Same thing applies with Azure, right? So, if you really wanted to, you could, you know, study a little extra for each of those, and you could probably take and pass all three of those from the material covered in this course. Okay. And I highly encourage you to at least get one, right? I would earmark one, you know, either your favorite one, or, you know, if you are looking at the most prevalent one out there, then I would look at AWS. They have more market share than everybody else. If you're looking at ones that would maybe land you a job, you know, eventually at Sandia, then you're going to want to be up on Azure, right? Because they have an Azure cloud, a private cloud. If you want to be, you know, I mean, Google, I think all three of them are practical. I think for our purposes here in Albuquerque, Sandia has an Azure cloud in place, and AWS is everywhere, right? Google is still maybe 9–10% of the total. So they're on the low end of the scale as far as market share is concerned. But they're also, I mean, I think it's valid. I've worked with companies that they use Google Cloud exclusively, containers and Kubernetes on Google Cloud to be specific, and it works really well. So knowing all of them is going to be good. All right, so that's our plan. I mean, I like to make sure that everybody's up on what we're doing. I know it hasn't changed, which is awesome. Like, so some of my other classes, I'm changing stuff because it's just things change. This class is pretty set. It's pretty solid at this point. So module 5 is this week. AWS Cloud Practitioner is next week. Cool. Let's jump out to our material real quick. So I believe this week the labs are like VPN related. I don't know if they're going to have you set up VPNs. I think they have you get started, but you don't actually. Yeah. So look at this, 95%. This class is doing really well. Right? Really happy with that. But VPNs, I think, is what we're concentrating on. So there's videos on virtual networks. Oh, that's chapter 4. I moved chapter 4 forward. So we're in chapter 5. So here's chapter 5. Yeah. So they are VPNs, right? And I don't think that I'm pretty sure that they don't have you do a whole bunch of like setting up of things like that, because yeah, when it says explore, right, they're going to have you go out and take a look at stuff, but they're not going to have you fired up. And the reason they're not going to have you fired up is it costs money, right? And it's usually pretty expensive to make the VPNs work. So you're going to be looking at VPN options and then cloud peering. And cloud peering is basically communications between VPCs, like within each of these infrastructures. Okay, so this chapter is more exploring. You're still going to go out and look at stuff. You're still going to log in and play with some things, but you're not going to actually fire them up, because when you fire them up, you're paying for them. All right. Fair enough. All right, so typical plan, right? Make sure you read, make sure you study, make sure you do the quizzes, do the labs. All that's going to be due on Sunday for chapter 5. So chapter 5, a lot of it's going to be, we're looking at hybrid versus in multi-cloud, right? So hybrid cloud is going to be on-prem and a cloud service provider. That's hybrid. And then multi-cloud is any combination of on-prem and a cloud provider, or multiple cloud providers, or just multiple cloud providers instead of nothing on-prem, but everything in the cloud, but using different providers. We're going to talk about configuring VPN connections and VPNs. We'll talk about VLANs and VXLANs and how we use those to manage things. This chapter is I don't want to say it's a primer, because it's actually going to repeat things that you should have already seen in your 1415 class, your networking class. You should have seen it in 1410 as well, right? But VPNs, VLANs, DHCP, I believe DNS is included, right? So we'll talk about DNS, we'll talk about some routing, and then we'll talk about some common network connectivity tools, right? So ping and traceroute and those kind of things. And then we'll look at what kind of networking issues, common networking issues that you will have in the cloud environment, right? That's going to be the bulk of the chapter. Okay. All right. So when we're talking about hybrid and multi-use cloud or multi-cloud, why would we use these things, right? So application development is one of those where you have, say you have developers on site at your office, right? And we connect them to, maybe like a GitHub server, and manage, we check out software and we move software. So we have to do a lot of this back and forth. Maybe if we want to do market testing, we would actually set up maybe different web servers on different cloud providers to see different marketing campaigns work. Cloud bursting is this really cool feature where, let's say we have an on-site web server where we maintain our web server, and let's say our web server is getting a hit quite a bit. Like we have a lot of, maybe we posted a video that goes viral or something like that, and there's lots of traffic, right? Cloud bursting allows you to launch another instance of your web server in the cloud environment. So you can pre-set up with any of these providers to have a copy of your web server, right, ready to go on a VM. And if we hit performance triggers on the on-prem based server, we will launch servers in the cloud to handle the overload. Okay, so that's a cool way to use hybrid. Okay, high availability and disaster recovery. So think about this from the standpoint of I could set up multiple web servers on multiple platforms and have them all communicate with each other so that we always have machines available no matter what happens to a particular provider. We could use some backup utilities that are out there that allow you to back up your systems to cloud-based services so that you can launch and run your company from the cloud if need be. There are, like if you have a Windows domain on site, you can actually set up a separate, and not really a domain controller, but you can set up Active Directory on most of these cloud-based services and tie your on-prem system to that. So if you lose the server locally, right, we redirect everybody to the cloud and they're able to log in and connect to the data that you have stored there as well, right? So lots of things where we would where we would be looking at, having both on-prem and in the cloud-based resources. And these are just a small sample of those things that we would use for that. Okay. Kind of taking this a little, a step further, right? We're again talking about hybrid and multi-cloud. So some benefits of going to multi-cloud infrastructure. A multi-cloud infrastructure would be, let's say I'm going to use AWS for some storage and web servers, and I'm going to use Azure for Active Directory, right? Because maybe we like Azure's Active Directory connectivity better than we'd like Amazon's, right? So for features, right, I'm going to use different services for different features. Or maybe, right, maybe we like the Azure Active Directory setup better, but AWS provides us the same or similar services, maybe not as nice, maybe not as easy to use, but maybe it's significantly less expensive. Not likely, but right, that's just one of the thoughts. Like I could, for cost optimization, I can move things from cloud provider to cloud provider in order to reduce costs. Like, especially if I have like a lot of server to server communications, right? Your best bet is going to be, say, Google, right? Because Google doesn't charge if you never leave their network, right? So if I'm going from one VPC to another VPC and I'm transferring data, that never hits the cloud, right? That always goes on Google's backbone, right? So there's no cost, egress cost or ingress cost for that. Another thing is edge locations. Like, I'm going to choose a service because they have a location closer to me, right? Closer to the edge, right? And that's where I'm located. I'm located at the edge, right? So if they have service, maybe I would pick a cloud provider because they have a closer location where I have less latency to connect, okay? Or disaster recovery. Maybe I'm running, say, web servers in AWS, and I want to back them up to a backup service on Google's cloud, right? So then I have them on two different platforms. If you know, maybe let's say AWS has an outage at my availability zone, and my servers go down, I have access to that data and I can get them refired on a different provider. Okay, so that's some ideas on why we would use different cloud providers. Okay, all of these things are going to go into your decision, like, you know, which providers are we going to use, and why, right? The reasons why. Anything that you're going to recommend as an IT professional, you need to be able to justify the cost and the time and the and anything else related to that. You need to be able to justify that as the right decision for the company. All right, and that's the most successful IT professionals are the ones that can balance business need with the technology, right? Because it's real easy as technologists to go with the latest and greatest, coolest solution. It usually costs more than it should, right? And we're not sure that if it matches to the business's what the business needs from us as far as technology is concerned. So one of the things that I feel like I did pretty good is I have a business degree. I don't have an IT degree or a CIS degree or a CS degree. I have a business degree. So when I went into the field, I had computer skills from it being a hobby of mine for 10 years prior to going into the field. And I had a business degree, so I understood what the companies were trying to do, and I could match technology to the outcomes that the company was looking for, right? So it was never about, let's do the latest, greatest, and the coolest. Let's do the most practical, the most cost-effective that gives us the right. So, and that's kind of what we need to think about here when we're thinking about cloud, right? What is the benefit that we're going to give the customer or our business from migrating to the cloud? Okay, I will tell you, like, early on, like, cost optimization, I think over time you'll find that cloud-based solutions are going to be more costly than non-cloud-based solutions. Okay, however, that didn't work. Nice. There are other reasons why we would do cloud solutions, right? Flexibility. We can do disaster recovery and mitigation a lot easier and a lot more effective than we could if we were doing everything on our own. There's capital expense versus operating expense, right? So how these expenses are taxed, right? And how they benefit or don't benefit the companies, things like that. So always kind of think of those things in mind. And we talk about a lot of that throughout the class. So me mentioning it today, it's just because I'm mentioning it, not because you need, it's covered. We'll cover it somewhere else at least once or twice. Okay. Now, we have these really cool benefits that we can put out there, right? But then we also have some challenges, right? So the very first one is the service and skill set portability across CSPs, right? It may be lacking. So by you taking this class, though, I think we mitigate that problem, I think, right? We expose you to all three, so you have a decent basic understanding of all three platforms. And I think any of you would be familiar enough with them to say launch some VMs, maybe learn how to set up a web server and launch a web server in a database, maybe storage buckets, things like that, things that you can learn easily, right? One step beyond what we've covered in the class so far, and you could do that on all three platforms, right? But most likely, what's going to happen is a company is going to think about going to the cloud, and then they will pick one. So let's say pick AWS, so then they'll train their folks on AWS, and not knowing that the services that they really need are on Google, right? Or on another service, because they don't have a person that's been trained in all of those, which is why I highly recommend you get at least those basic entry-level certs. They all cost about $100 a piece. But that will show a potential employer that you have a skill set across all three platforms, right? Another problem with, or challenge with, hybrid clouds and multi-clouds is this cross-network connection creation and maintenance, right? So if I'm a hybrid cloud and I want to communicate to a cloud-based solution, I've got to set up VPNs, and I've got to maintain those, and I got to make sure people have access, and I'm protecting my data while it's in transit. If I'm connecting I'm connecting Azure VNets to AWS VPCs, I've got to create VPN connections and routes between those. So there's this fundamental networking that we've got to be really good at in order to be able to make these things happen. So there's, again, that's a skills thing. Like you've got to know how to build those, and you've got to know how to put those out there and what to do with it, right? And then security measures, like how am I going to protect the data within my on-prem and each of the cloud services, and then as I move stuff between, right? As I move data in between, I can't not secure them, the data. So I got to make sure that I'm aware of that as well. Okay. So, portability of skills across the platforms, this extra layer of network connectivity that I've got to deal with, and this extra layer of security would all be things that would be challenges to that offset, the benefit of cost, optimization and features and that kind of stuff. Okay. Stuff you need to be aware of. So the easiest thing that we would do is, so your options, I guess your options for connections, right? The easiest is to just use the open internet, right? Which would be a disaster, right? You're never going to want to just pass your data across the network, the internet, without protecting it in some form or fashion. Okay. HTTPS, right? When we're using web-based services, VPNs, when we're using direct data connections, that kind of thing. So you're going to have to learn how to set up VPNs and how to maintain VPNs. What they are is a virtual private network between two geographic locations. You can set them up from your site to your Google or your cloud service provider VPN connectivity. You can create a gateway, and you can do site to site. You can also set up point to points, not point to points, but client to sites. So that would be VPNs on, say, laptops, and if they want to connect to the network, they've got to fire up the VPN and connect to the network. For those of you that have taken any of our server classes in the last couple of years, VPN, well, actually the last year now that we've had VPNs up and running, we actually connect to the school's network with VPNs, and that's secure communications between your PC and the office. That's the same kind of thing we're talking about here, that you would be setting that up from your computers to your cloud service providers' data networks. Okay. It creates an encrypted tunnel. We call it a tunnel. Okay. And I'm a big fan of making sure that you understand that it's really not a tunnel, right? But it's the best way to describe what's happening. Okay, because the other way to describe what's happening is, in the way I like to think about it is everybody on this call should be familiar with Twisters, right? The burrito company, right? So I want to go order a burrito. So I drive up to the drive-through, I order a burrito, right? And I'm driving around to the window. Okay. So think of the space between my car and the window as the internet, right? So anybody could stand there and watch things go back and forth between the window. Oh, that's a soda, or that's a, that's a burrito, or that's a burger, or whatever, right? They can see the packages go back and forth. Okay. So let's think about a burrito, right? So let's say I order the number 8, right? Carne adobada, right? And they bring it to me, but it's wrapped, right? It's wrapped in this aluminum foil package. Okay. So somebody observing this exchange can tell that it's a burrito, but they can't tell what's inside the burrito, and they can't read the burrito unless they get a hold of the burrito, right? And they have to unwrap the burrito before they can figure that out. Okay. On the internet, that wrapper is locked in such a way that it would be really obvious if somebody opened up the wrapper. Okay. In our environment, like, I would see the person because, right, they would be right there. But the idea being that they can't see what's in the wrapper. They don't know that I ordered a number 8, right? They don't know that, right? But I do, because I'm the one that's going to unwrap it on the other end and eat it, right? Because that's the piece that I ordered. But that's kind of how a VPN works. We're going to take every single data packet that's going to go from the window to the car, and we're going to wrap it in this nice little package, and they're all going to look the same, right? And everybody can tell that they're data packets, but they can't tell what's inside the data packets. Okay. So it's not like it's not like I roll up to the window and I pull out a big 8-inch piece of pipe and I drop it into the window and they shoot the data through the tunnel, right? That's not how it works, right? It's clear and obvious that they're passing data, but they can't tell what's inside the data. Okay. So again, I don't know why I feel like I need to explain it that way, but just tunnels, right? We call it a tunnel. It's always a tunnel, but remember, it's just packets, right? They're just data packets, and we encrypt every single data packet so that you can't tell what's in the data packet. Yeah, I'm hungry too, right? It's dinner time. Let's call this. I have to do class until 8:30. What are you talking about? Does that make sense, right? So we say it's a tunnel, understand it's just data packets going back and forth, and we wrap them up in these nice tight bundles where you can't see what's in the data, okay? So you would create VPN tunnels, right? So here's my customer data center, right? So my customer site, on the customer site, we create this customer VPN gateway, okay? And that creates a tunnel to a virtual VPN gateway that sits on the AWS side. So this, right? We're not really getting to go through this cool little slide thing here. We're just sending packets across the internet, but they're encrypted, and they go from here to here, right? And if anything interferes with them, it will be obvious to either side that they were interfered with, and they can be dealt with pretty much right away, right? All right, so that's kind of what we're talking about, is that you would have to set this up, right? And you can set it up from an on-prem data center or an on-prem your office. It doesn't have to be a data center. It can just be your premises, right? Or you can have a computer that sits out here and it has a VPN connection to this gateway as well. Okay. Yeah, no burritos, no slides. Like, I'm just ruining it. I'm ruining it.
Feeling all the fun.
Sorry. Most VPN tunnels operate at the layer 2, right? So layer 2 is at that MAC layer. We encapsulate everything else. The VPN frame is encapsulated. We're going to show a picture of it, what that looks like in a minute. Some tunnels work at layer 3, which is the network layer, the IP layer, where we have IP addressing, and some even work one layer above that at the layer 4 layer. Okay. And what we mean by that, let me just grab this. Right, here's my burrito, right? And these yellow pieces and this purple or this blue piece, right? Everything between the blue pieces, right? Those are all, that's the wrapper that goes around the burrito, okay? And in this case, right, we've got an IPsec, which is a security header. And then this is the TCP or UDP. This is where, how we're communicating with the device, between the devices. The VPN header is going to include, it may include the IP addressing. The IP addressing may actually still be in the payload. Okay. Yeah, carne adobada, right? Number 8. Good go. So, right. So in this case, right, the original frame, which is our data, that's going to be the payload. And then we're going to wrap it with all this other material that my machine, my computers and my gateways all understand how to deal with that and get the traffic from one side to the other without anybody seeing what's in the payload, right? And then be able to unwrap it on the other end and consume it on the other side, right? Right, excellent. There are a bunch of different types of VPNs that they want us to know about, okay? And you'll need to know those for most of these quizzes or these certifications. There's some reference to VPNs. You have point-to-point tunneling protocol, PPTP, right? It's outdated, it's not used. However, it's still around, so you may run into it, which is why they continue to leave it, which is ridiculous. It should be gone. It doesn't have a good enough encryption process at this point, okay? That's been replaced by layer 2 tunneling protocol, so L2TP. And we're gonna use IPsec, right, which is internet or IP security, right? So it's an encryption algorithm that we would use. And lots of vendors use L2TP or have that available. There is another one out there called the generic routing encapsulation. This is a layer 3 protocol. So this is at the TCP or the IP layer where we do the IP addressing. It uses IPsec as well, but it's not supported very much, okay? Most companies or most cloud providers will use one of the next two, either OpenVPN, which instead of using IPsec is using OpenSSL, which is secured socket layer, right? Which is the same protocols that we use to secure our web traffic, HTTPS, right? That's the same, SSL is the same security. And in fact, we actually don't use SSL any longer. We use a protocol called TLS, which is a derivative or not a predecessor. SSL was the predecessor to TLS, right? It's just kind of the evolution of SSL. But OpenVPN, right? Highly secure, it's highly configurable. Lots of companies use it. It does use an open encryption technology that is pretty good, right? And then you have IKE, which is Internet Key Exchange. This is where you don't have to have communications before you get started. You can use public keys and private keys to make things happen. And if you can run with IKE, that's what most people recommend as far as the best security that you can do right now. So IKE version 2. So IKE version 2, OpenVPN, L2TP are going to be your 3 choices as far as putting together an encrypted VPN, going from IKE as the best to OpenVPN to L2TP, right? So just be aware of them. You're going to kind of look at some of those things when you play with your labs. Another way for you to connect to your, right? So that's VPNs, right? So we can connect just right to the internet without any kind of VPNs. That would be crazy. We can set up a VPN and connect to our data center that way, or to our cloud service provider, sorry. Or we can do a direct connection, okay? Which would be you could use a colo as well. So direct connection, I want to show you this because I don't know that if you guys know this exists here in Albuquerque, right? So Big Byte, have you guys heard of Big Byte? Whoops, I should spell it correctly. All right, so Big Byte, if you watch the video down here, they're down across the street from, there's a concert hall down near the movie theater on Central. Tucano's is right there. Sunshine, the Sunshine Theater, right? So right across the street from the Sunshine Theater is this, they don't show it in this picture, but the building it's the building straight across the street, okay? So in that building, there is a data center, right? They've done a really good job of hiding this data center, right? But this data center sits right on top of the fiber loops that go downtown. So it sits right on top of all the major telecom providers, and you can co-locate. You can actually set up your own data racks in their server rooms, right? And you can have your own section of stuff. They'll maintain it. You can maintain it. Whatever works for you. You can have your own systems located in their data center, and you connect right to the fiber that's located in that's connected to their building. You can pick any service provider that you want to pick, the ISPs that are available downtown. You can also, they have office solutions. Like if you need, to have a desk or a set of desks, or say maybe your office, maybe your office had a flood, right? And you had a pipe burst and you need temporary space. You can rent temporary space, or you can rent permanent space from them, connect it, and you can have your servers right there in their data center. Some pretty cool stuff there, right? You can connect to a ton of really good, yeah, that never happens, right? I've had that happen, I don't know, half a dozen times in my career. I've had a tornado go through a customer's building and literally take the server and throw it 3 miles down the road. So, not here in St. Louis, but so you can see, you can connect to CenturyLink, Cogent, Comcast, Lobo Internet, right? United Private Networks, Verizon, Zayo. They got a ton of good connectivity officers down there, right? So pretty cool stuff, right? That's why I think I mentioned in our last class, or I don't know if I mentioned in this class, but like we're in a really good place technology or weather-wise. The important thing I want to bring up, right, is they have cloud computing, and you can connect directly to AWS, Google, and Azure from their location, right? So you can actually create a direct connection to these solutions in Albuquerque, which I was like, what? Okay, that's awesome. But what? I didn't realize we had that. So that's pretty cool. So yeah, so that, I don't know. I think I want to contact these folks once we have, we're past pandemic, and I would love to see if we could get, a tour, right? Set up for hackerspace students or anybody who wants to go with us. Because I think it'd be really neat for, for CIS students to see a live data center, that, that's a commercial data center like this, right? There are really, there's really huge ones. I can't remember the name of them now, but there's one, I have a buddy of mine that I just never got around to getting it done, but he could have got me into the data center. They actually have armed guards at some of these data centers. That's how important this data is in some of these places. I was like, wow, that'd be crazy. Armed guards at a data center. All right, so you can colo, like I can put my data center, I can put my servers down at Big Byte, and I can connect direct connection to AWS, right? Yeah, nerd out on your own server room. I love it, right? I've done that before. I've owned my own data center before. So anyways, keep on trucking, right? So direct connection, VPNs, I can colo my equipment, right? If you want to connect directly to AWS, they call it Direct Connect. Azure calls it Express Route. GCP calls it Cloud Interconnect, right? And I only bring these up because you gotta kind of know these terms, because when you talk to somebody at Azure, they're going to say Express Route, and you're going to be like, what? What does that mean? And then they'll explain what's going on. Okay, here's what it looks like. Here's my office. Here's Big Byte, right? And Big Byte has direct connections to AWS and all these other ones. They may have, because they have bigger pipes, they may have other connections to other remote co-location facilities. So I can get maybe to Alibaba, or I can get to Oracle or IBM or somebody else through a connection through the co-location facility, right? So co-location facility is going to be in our case, right? Albuquerque, Big Byte, downtown. I can put my servers in there. So I can put some equipment here. I can put equipment here. I can connect them VPN, and then I can direct connect to my services on the cloud. Right, so totally good stuff. Excellent. Cloud peering. So cloud peering is this idea that I can connect different networks, right, between different ISPs. In the cloud, I'm going to be connecting VPCs on one system to VPCs on another system, right? There are always going to be charges if you're connecting your VPCs, right? So if I set up a VPC, say US East, and I set up a VPC US West, and I want to have a communications channel between those two, you can do that. It's called cloud peering. However, there's a cost involved with that. But so that allows me, though, to have different locations around the globe where I can house my equipment and then have them communicate with each other. Okay. looks something like this. Just because I have a cloud peering between A and B and C does not mean A and C have connectivity. Okay, this is only this direction. It's not transitive. Okay, so in the cloud environment, it's not transitive. In say Windows environment, it would be transitive by default. So when we're doing cloud trust and stuff like that. All right. So VLANs. So one of the ways that we would kind of facilitate networking in our environments on-prem and in the cloud is the studying of VLANs, right? Using different switching and routing configurations to provide network connectivity, right? And I think there's actually some decent graphics going on down here. So this is a strange setup. I've got a router, a single switch. That's not a strange setup. This is kind of a normal setup in a small business, right? And let's say I have a VLAN for phones and I have a VLAN for data, okay? Now, in the switch, it won't allow me to move traffic from one VLAN to the other, okay? So the switch won't allow this to happen. So when I have this situation, what I have to do is I have to hang a router off here, and this is called router on a stick, right? Because we just stick it out here. And what's happening is now I have a trunk out to the router, and the trunk can handle the VLAN traffic from both VLAN 1 and VLAN 2. So if I have traffic and I have rules set up properly that needs to go from VLAN 2 to VLAN 1, it would go from VLAN 1 to the switch, up the trunk, go through the routing table, and then back down the trunk on VLAN 1, back to VLAN 1. Okay, so this is a kind of a common, and then this would be connected to the internet. So this would allow VLAN traffic or separation of traffic in our network. So even though these computers or these phones are connected to the same switch as these computers, because they are logically organized as VLANs, they cannot talk to each other. Okay. On the switch without having some kind of a routing capability built in. All right. The next scenario is something like this. So I have a router on a stick. I've got a switch that's connected to switch A and switch B. So then everything in purple here, it looks purple to me. These are trunks, right? And on this switch, I've set up VLAN 1 and VLAN 2. And on this switch, I've got VLAN 1 and VLAN 3. So VLAN 1 would trunk to VLAN 1, and they can always communicate with each other, right? No problem. If I want VLAN 2 to communicate to VLAN 3, VLAN 2's traffic is going to go to switch A, trunk to switch C, trunk to the router, be routed properly back to switch C, trunked down to switch B, and over to VLAN 3, right? Or VLAN 2 to VLAN 3. Okay. Does it make sense? So this is a expanded version of a router on a switch, but I've got two switches, and we're showing you that I can set up VLANs on different, the same VLAN on two different switches, and they would communicate as if they were on the same switch. Okay. This is, you may have seen stuff like this if you took 1415. If you are interested in kind of how these things work, like the Cisco CCNA track, CCNA 1, CCNA 2, CCNA 3, you build these kind of things all the time, right? This is kind of a normal kind of build starting in the second semester. Now, we talked about VLANs, right, which work right here on an on-prem system, okay? There's another type of VLAN called a VXLAN, right, virtual extensible LAN. And what that's going to allow me to do is to extend out over virtual connection. Right? So in this case, I've got a network down here in Nashville, and I've got a network over here in Tallahassee, and I've got the internet in between. Okay, and this is what we're going to call this is our overlay network. This is our VPN network. So understand that all of this is happening from here to here across the internet. Okay. So I've set up VXLAN, which means I can set up a VXLAN on this network and a VXLAN on this network, right? Two completely different networks. And I can tunnel through these two virtual tunnels right here, right? And I can actually have computers in Tallahassee and computers in Nashville think they're on the same network, okay? Now, I could make this, instead of being another physical location, I can make this location here a cloud-based location, right? So this could be an AWS VPC, and I could be able to set up VLAN tunnels where I actually have computers over here on-prem that look like they're on the same network as VMs on the cloud. Okay. So VXLAN is going to give you this ability to kind of tunnel through the internet, directly through the internet, right? And create VLANs on completely different subnet infrastructures. Okay. It's a lot more detail than we need today, but VXLAN, there's an extra header in here that we play with. Okay, so the original L2 frame, which is that's layer 2 frame, that's going to be the MAC address, right? The rest of the packet continues on out here, but there's this whole bunch of extra header information that goes on to a VXLAN. And when you have VXLAN set up, your equipment understands how to read through it all, and it knows where to route everything. Obviously, if you've set it up correctly, you can route it properly. Okay. So be aware of VLANs, VXLANs, be aware of VPNs, direct connections, co-locations, right? DHCP, right? So again, we're another topic we introduced back in 1410, 1415, right? So DHCP is dynamically addressing IPs, right, to your equipment. Normally you would set up a DHCP service on your network and allow it to create a lease for particular IP addresses. You set up your default gateways, your DNS service, things like that, and you hand that information out to your clients, your end users, computers, right? In an on-prem situation, it's it's a service running on one of your servers, right? Or your firewall or a router. Right? And this is, if you had a small network at home and you're using TP-Link, this is where you would set it up. Right, this is on the network DHCP server. We're giving away 192.168.2.100 to 2.199. We're leasing the address for 2 hours. We're giving you a gateway of 2.1, and we're using Google's DNS servers 8888 and 88.4.4. Okay, so that's just a real simple DHCP setup where we can connect people to this particular router. I'm not sure if this is a wireless router or not. It could just be a wired router, but that's just a basic setup. Okay. Now, where it gets confusing is, can I set up DHCP in the cloud, right? And all the VPCs that we set up, they are set up with DHCP, and you can configure them to your liking. You can also share the DHCP setup with your on-prem stuff, right? So in the cloud, you can set up the DHCP, right? And this is just an example. Here's your VPC, and on the actions for the VPC, you can actually change your settings if you wanted to, right? And you can control the IP addresses that are given out and not given out on the VPC, okay? Combine that with VXLANs, right? And you can actually then start combining your online cloud-based networks with your on-prem networks to create a common DHCP schema. Okay, I'm going to skip over a couple of just detailed slides there. If you're going to do, if you want to control DHCP across your on-prem and in the cloud, they're recommending that you use IPAM, right? So IP address management. And I don't think we have it anymore in our server classes, but we used to do IPAM in the 2630 class, and it was probably the hardest chapter of all. It was just it was so crazy to get your head wrapped around what was going on with this. But an IPAM tool allows you to combine DHCP and DNS across your network and manage everything from one space. So even if you have, say, 4 or 5 DHCP servers and a couple DNS servers, it all can be managed from one utility, one tool. It takes a while to get it stood up, and working properly. But once it's up and running, they're really cool tools. There are a couple, and I've never tried them before, this InfoBlocks and Fusion Layer, that may be better. IPM, IPAM isn't built into AWS or Azure, so you have to do some other third-party kind of tool to make it work, okay? But IPAM will give you this ability to manage all of the different IPAM or DHCP services within your network, okay? And that's only a big deal if, for example, if you have a network the size of CNMs, right? 8 different locations and, you know, thousands and thousands of computers, right? They run an IPAM system so that they can manage all the IP addresses everywhere from one console, okay? As a sysadmin, the fewer consoles you have to deal with, the better, right? So if I don't have to log into 5 different places to manage all the things, I can log into one and I can manage 5 different services, then that's a lot better than the opposite of that, okay? Taking DHCP to the next level, right? DNS, right? We usually in DHCP, we hand out DNS servers, right? We can, through DHCP, control what DNS servers our machines look at. And in fact, you can actually host your DNS services on AWS, Azure, and Google, right? So you can actually, like, I think AWS calls theirs Route 53, right? It's Route 53 because you're routing, and 53 because 53 is the port number used for DNS, okay? So Route 53 is AWS's DNS services, and you could actually set up your DNS services on Route 53 and have it manage your DNS for your on-prem and your cloud-based solutions, right? So pretty cool stuff. So part of this, right, some of these things, and I'm kind of skipping over things that I feel like, you know, I know you covered twice already in previous courses, the different types of records and things like that, the time to lives. And I know when you read the book, there are several places where it says, hey, go back to this, you know, go back to this book and read this section if you need to fill in the gaps as far as your knowledge is concerned, okay? It's perfectly fine if you don't have that knowledge today, but it's not fine if you continue to move forward without kind of digging through and getting that, you know, under your belt and understanding what we're talking about DNS wise, okay? So you can set up your own DNS servers in the cloud. You can actually manage your DNS on-prem and in the cloud using a cloud-based DNS service. That's some pretty cool stuff. That simplifies a lot of things from the standpoint, again, we have one place to go. I'm not locked into having to buy equipment to do this on-prem, or if I wanted to have it on-prem, I could have it forward information out and I would control you know, what the DNS lookups look like and things like that, okay? So there's lots of cool things that you can do with DNS around making sure you manage your network properly. Fair enough. Routing, right? So we've kind of talked about routing more from a on-prem solution. You can set up routing that will route data to your cloud VPCs and VNets, and in doing so, then you start establishing, like, I mean, it becomes more like a regular network that you would manage. You can set up automatic gateway protocols, or what they are, I'm sorry, automatic protocols, right? That will communicate, each of the devices communicates with each other to figure out the routes. Again, if getting into routing is interesting to you, that's again another CCNA Cisco class kind of a thing, because I know in there we do RIP, we do OSPF, and I think eGRIP are the 3 that we do in that class. And you might do IS, maybe. I think with most of the stuff that you're going to work on in this class, and then what you would work on with cloud-based stuff is going to be using BGP, which is Border Gateway Protocol. And that is the kind of the most comprehensive of the protocols out there. It's the protocol that the bulk of the internet works off of. All right. When you're setting up routing, so you've got to, if you're setting up routing, right, from on-prem to cloud, then you're worried about, how we're going to communicate. How do we learn routes, right? We need to worry about where the VPNs are going to terminate. Okay. And when they terminate, how does the traffic continue on from there? The routes being shared is called propagation, right? So as routes are shared, they get propagated, and then they eventually get to a point where everybody has the same information. And the quicker that system gets to that point, the better. So that's why you would, when you're researching what type of a protocol you want to use, that would be where you would choose, or part of the reason why you would choose a particular protocol, right? Is how quickly it converges. For us, right, and I think the examples that they're going to have you look at are going to all be using BGP. Trying to think if there's anything else that needs to be dealt with there. I don't think so. More networking, right? So we're talking about networking services. We're talking about DHCP, DNS, routing, right? We've talked about VPNs. We talked about VLANs. Load balancing is another key factor that we would play with. A lot of times it's better to just look at pictures. So we got online users connected to a web server. And what I do is out front of that, I put a load balancer. The load balancer takes in all the inbound. Yes, picture books, right? I love them. Diagrams, network diagrams are the best, right? Because then it's a whole lot easier to understand how this works. I think maybe I'm mistaken, but I think it's so much easier to figure this out this way, right? So online, right? A bunch of them coming in. We're going to funnel them into the load balancer. The load balancer has in the background server clusters, right? And what it means by that is I've got maybe one server online, maybe two servers, maybe I have 4 or 5 servers. And what it will do, depending on the rules that I've given it, maybe the rule is always send the traffic to the least busy servers. So if this server is 50% busy and this one's 40% busy, the traffic would come to this server. If I have a third server and it's 20% busy, then it would go to that server. And then the next piece of traffic that comes in, it looks at the rates, and maybe the user that was using this server now has dropped off and this server's at 10%. So I'll drop it up here, right? And then maybe that user stays on there for a long time and it's at 60% the whole time. And this one drops down to 20, so I drop it here. So based on the load of the servers, I would balance between the servers, okay? Also, there's another graphic coming. I could do a round robin, right? And a round robin is first bit of traffic goes to web 1, second to web 2, third to web 3, fourth to web 1, fifth to web 2, right? It doesn't even bother looking at how much traffic is being handled by each server. I'm just going to go in a circle, right? So there's a couple of different options that you have there. Those are 2 examples. There's other ones. There's other ways to do load balancing as well. In fact, you can now add elasticity to this. So you can say, I have a load balancer. I've got 2 servers, and then I've got an image of these servers, queued up and ready to go. And the load balancer is like, okay, 50% busy, 50% busy, 70% busy, 70% busy, 80% busy, 80% busy. Wait, you're 80% busy. Launch a new server. Give this to the new server. 10% busy, 80% busy, 70% busy, right? 10% busy. Load it, load it, load it, load it, load it. This gets down to 50. This is 50. This is 50. Then I start going, 60, 60, 60, on and on, right? So I can use another tool called elasticity that will auto fire up servers and then take them down. So then let's say I get to, okay, we're at 20, we're at 20, we're at 20, kill off one of these servers. Now I'm at 40, I'm at 40. We're good. We're 40, 40, 40, 30, 30, 20, 20, 50, 50, 70, 70, 80, 80, wait, 80, 80, this will fire up another server. Okay. So depending on how you do this, right? So load balancing will work with elasticity, allowing you to spread the workload over a number of resources that allows us to make sure that we handle the workload as efficiently as possible. Okay, so round robin, I've already talked about that, kind of looked at that picture. Sticky sessions. So this is the next piece that we can go back to this number 1 picture here, but let's say online user comes into the load balancer and it's given to web server 2. Now, all communications between online user 1 and web server 2, it stays there, right? I don't take a look at the next piece of traffic and move that traffic to another server. Sticky sessions will keep these sessions connected. And then if I'm going to shut down this server, it will close out properly all of my connections with so if I've launched an extra server down here, right, and it's at 10%, I got one user connected, it will not shut down until when we get to the point where it decides to shut down. That's the first step, right? We're going to shut this server down. It will maintain the connection to whatever user is using it until that connection is completed, and then it will shut down the system. It won't migrate that user to another server. Okay, so sticky sessions allows us to maintain connectivity to the same device. Okay, so you can load balance at a bunch of different layers, right? All the major cloud providers have load balancer services. They handle traffic in and out of the connections. They all depend on what layer they're communicating at. So AWS has a layer 7, right, which is at the web layer, right, the application layer, and they have an IP. So based on IPs, right, I can do this based on IPs, or I can do this based on what type of web service you're using. Okay, GCP has layer 7 and a layer 4, right? So layer 4 is a TCP or UDP layer. They don't get down to layer 1 or layer 3, which is the IP layer. Okay, so I can do web-based traffic, or application-based traffic, or connectivity-based traffic. Okay, and then Azure only has a layer 4 balancer, so they only do it based on the type of TCP or UDP connection. So if you have a TCP port 80 connection, we can balance those between machines, right? And that's kind of what we would look at on that. So each one of them has different types of load balancers. They provide different levels of service. If we think back to like slide number 2 today, right? What types of services do I need? Do I need a layer 7 load balancer? And if I do, then GCP and AWS are my only options, right? If I need a layer 4 load balancer, I'm worried about balancing based on the type of traffic, then I'm looking at GCP or Azure. If I need it based on IPs only, right? I only want to filter and load balance on IPs, then maybe layer 3, I would be stuck with AWS, right? So depending on what types of services they provide, will allow me to actually do would drive what kind of system I use, right? So you can, I don't think it says it, I don't know if it's here or not. Yeah, you can, using load balancers, I can load balance from my on-prem to the cloud and vice versa. So if I have services that are on-prem and they get overloaded, I can route traffic to the load balancer and have it balance on with a cloud-based solution. Or I can actually have an on-prem server and a cloud-based server, and everything goes to the load balancer, and it's divided up between the two servers, right? So it's not only, right, this cloud-based only system, right? This server can be on-prem, that server can be in the cloud, and I can use a load balancer to go back and forth between those. All right. Cool, cool, cool. Last little piece, common CLI troubleshooting commands. Okay, so ping, right? It's a common command we use all the time to connect, check connectivity. In fact, we used it in the last class to check connectivity and to make sure that I can get to where I needed to get to, right? And in the process, we learned that my firewall was blocking stuff, so we turned off firewall stuff. Okay, so ping, right? We'll do that. It's almost one of the very first things. ipconfig and ping are like the first two things you ever do, right? ipconfig, right? If you're on a Linux machine, you can use ifconfig, or now they have the new IP command, right? So ifconfig or ipconfig on a Windows machine, ping. Those are my go-to tools to understand what the network looks like, to understand if I have connectivity, right? In addition to that, yeah, is it plugged in? You can use traceroute. If you're connected to cloud-based solutions, that starts to make some more sense. A lot of times in my past, when I used traceroute, I usually discovered that the data was lost like 2 or 3 providers later, and it was outside of the realm of responsibility for, for us. I couldn't do anything about it. But it's not, I don't know. I haven't found a lot of value out of traceroute. I think if you work in a big organization and you're trying to figure out why you can't get from one location to another within your organization, I think traceroute would be really good. Or if you just want to see if you can, request timed out all the time, right? Just not there. So then they, netstat, ARP, and NSLOOKUP or dig, right? So these are all commands that, again, you've learned these commands all the way back to 1610. We didn't talk about them in 1410. We talk about them in 1415. We talk about them in 2670. Right? These are all commands. These are all command line tools that we can use to see what's going on. Nice. Hey, you can get AARP at any age, by the way. It only costs $16 a year. They don't care if you're 60 or 15. So AARP, nice. What are you saying? I'm done. This class is over. You just made me mad. I'm kidding. It's a joke. All right. Anyways, netstat, ARP, and NSLOOKUP are all going to be additional tools for you to gather information about what's going on. What does my network traffic look like? What does my MAC address look like? What does my what ports are opened on my machine? That kind of thing, right? These are all tools that we would normally use in our regular communications on our regular network. They all apply here as well. If I'm having communication problems with my cloud-based services, I'm going to want to make sure that my system hasn't been interfered with, that I've got good communications, I've got ping communications, I've got traceroute communications, right? Like they're just doing a netstat command? Yeah, so netstat command, you can see that I'm using SSH, established an SSH connection, right? And it tells you what ports and stuff. So you can see that, yes, I do have communications or I don't have communications, right? Good stuff. Good stuff. Here's your AWS instance was automatically given a public IP address. So you have an IP address and a, this FQDN, right? Fully qualified domain name, right? So they're automatically given when you create those things. And you guys have all seen that already and are familiar with that. And then we could ping that. We can ping the IP addresses. We can do trace routes to those addresses, right? All kinds of fun things that we could try. Okay. Here's an NSLOOKUP of the actual IP address, and it comes back with, right, my fully qualified domain name. Right, so lots of good things that we can do, right, with these tools. TCP dump, right? So this is the Linux or Unix command. It's good for troubleshooting VPN connectivity. So if you're on Linux, right, TCP dump. There's a route command. You can use telnet to connect. Not right. This is the reason we wouldn't want to use that. Unsecure. You can try to use an SSH to connect. That's going to be using port 22 and be secure. Again, all these are tools, command line tools that'll let you troubleshoot your connectivity to your cloud. In fact, they'll help you troubleshoot connectivity to any device, not just cloud devices, your routers, your firewalls, your printers, your other computers, your servers, whatever the case may be. Okay. Last 3 slides real quick. If you have an unreachable instance, right, you cannot connect to a VM instance. Maybe the VM's OS or connectivity settings internally or externally to the VM. So there could be a misconfiguration on the VM itself. The VM may be down, right? It may be turned off. It may be unavailable, right? We want to make sure we kind of take a look at what's going on with the VM, make sure the VM's up and running, make sure the VM can communicate to the internet, right? Those kind of things. And then once we have that, then we can then start troubleshooting using those tools that we just talked about to connect, to figure out where along the way we have the problem. Okay. If you have slow connectivity, right? Insufficient bandwidth, right? So you maybe don't have enough bandwidth to connect and it's just going slow. Maybe there's a problem with latency. Maybe the distance is really far. and latency latency is a problem. However, if you ping, raspberrypi.org, which is in the UK, you get a response back in millisecond times. Like, so latency, I think would be at that point either a bandwidth problem or a resource problem. I'm thinking resource problem on the server itself. Like, it doesn't have enough resources to handle everything. Or you have some crazy routing, configuration or network configuration that's causing, delays or problems. Okay. Understanding, right, just getting a good understanding of your typical underlying problems, right? So if you having these issues and I run all these commands and I can connect and I can, but I'm still slow, then there's going to be resource problems, right? Or bandwidth allocation problems or some other external issue that's causing me issues or causing me problems. Right? If you can't reach, right, we're still on unreachable, right? So incorrect IP address or incorrect subnet. So maybe we've got, when we tried to make the connection, we set it up wrong. Maybe I have a DNS error. Maybe I'm pointing to the wrong place, or DNS doesn't have a record, right? Maybe misconfigured firewall rules. That was what we had problems with earlier in my earlier class. I just had a firewall that was blocking all kinds of stuff, right? So these are all, these are common things that you would do for your on-prem stuff. You're going to do the same thing for your cloud-based stuff, right? Because just think, it's just a server in a network, at AWS or at Azure or GCP. Okay. We also could have incorrect routing or incorrect gateway. So maybe I'm pointing to the wrong place, or maybe my routing tables aren't pointing to the right place, so I don't have good connectivity, or I don't have my data is not getting to the right place, right? Maybe my VPN tunnel is timed out. Maybe I've been disconnected. Maybe I can't authenticate properly. Something along those lines, right? So maybe there's a tunnel issue. Right? And if you're using proxy servers, which we haven't talked about and don't typically use, maybe the proxy servers misconfigured as well, right? So with unreachable instances, we got all kinds of stuff, right? We've got bandwidth issues, we've got IP address issues, subnet issues, DNS issues, firewall issues, tunneling issues, routing issues, proxy issues, all the same kind of things that you would normally have on a regular network, okay? Lastly, I believe it's QoS, quality of service. So if you've got quality of service turned on your network, maybe it's bandwidth limiting your connectivity, and you need to readjust based on the type of traffic that you need to pass along. Okay. Yeah, like when a wrapper's on backwards, right? Exactly. Awesome. All right. So those are going to be your troubleshooting ideas, right? And this is just specifically getting to an unreachable instance, a VM on a cloud-based service that I cannot connect to, right? You've got about 10 different command line utilities that you could use to try to figure out what's going on. And then you've got places to look: DNS, DHCP, routers, VPN connectivity, QoS, like all these different things that we could possibly take a look at. All right. Any questions? We kind of rush through some of that. I think a lot of that's going to be, I'm hoping that a lot of that is kind of repeat of things that you've done in the past, in previous classes. Like I said, this session, you're going to learn about the network, and then you're going to look at the network. You're not actually going to set up the VPNs, but you're going to look at them. You may get started on the VPN connectivity, or may have to just go look at where you would go to set up VPNs. VPNs typically cost money because they require the gateways to be turned on, and the gateways are expensive. So in this case, we're going to be looking at lots of things this class or this module. Fair enough. Are there any questions at this point? Right. Just wanted to make sure we didn't have class on Monday. Normally would have covered this in 2 sessions, did a little bit, done some work, done a little bit, did some work. But because we didn't have class, I wasn't able to, I wanted to make sure that we covered the content for sure. And I know the labs this week are more looking at things than they are actually doing things. So it's shouldn't be overly burdensome from a
Well, I
work.
have an after class question, but I'll wait and see if anybody has any actual like class questions for you
Okay.
first.
Awesome. If you don't have any questions, you're welcome to drop off. We'll be done a couple minutes early. It's 4:58.
I'll go ahead and ask mine since nobody else seems to be asking.
Yeah, I don't see anything. They're all ready to go. I want to go eat dinner. I'm going to go to Twister's and have dinner.
I was just wondering. I think I'm pretty well caught up at this point. I know I think I'm a couple days behind on a couple assignments now, but I mean, I think remember before I was like at 27% done or something. I was behind. Am I correct that I'm reasonably well caught up at this point?
Yeah, I think so. I'm not sharing the screen, so it should be. I'm gonna go look it up real quick.
Cool. I mean, I don't care if it happens to come up with whatever.
I know, but I don't want to. I don't want to have any problems. So. FERPA rules are FERPA rules. So.
Yeah, true. Fair enough. But
I've had a couple of recordings where somebody in the chat's like, well, you're showing us the grade book, right? I'm like, oh my god, like I freak out and close, just delete. Kind of.
Never saw that. It never happened.
Oh, I've tried to get to, and I've got my VPN up and running, so I got to turn off my VPN.
Oh yeah, that's something you should talk to them about. See if they.
They won't. We've already had that discussion with them. We've already had that discussion with them. They are adamant that we're not allowed to bridge across, and that doesn't make any sense.
Okay.
They don't. It doesn't make any sense at all. But whatever.
Yeah, I was gonna say. I mean, all they got to do is tell the DNS there at the gateway that hey, go ahead. And
you would think it was that easy, but it's not.
Yeah, fair enough.
Yeah. There's a lot of red tape. It took us long enough to get the VPNs working.
Right.
So
you don't wanna...
we're not rocking the boat at all.
Yeah, exactly.
Like I'm not going to rock anything because I don't want there to be any delay for you guys getting
pushing it a little bit. But...
Yeah. So at this point, like we've got it working. There's a little, kind of weirdness on the vSphere side but we don't control it, but we have somebody who has access to making things work for us. So that's fine for us. So, and I'm not sharing, right? My screen's not being shared.
No, I just see you on my screen. That's all I see.
All right. Yeah. So from a grade point, so in the, 98.5, I think you're fine.
98.5? Cool.
Yeah.
Yeah. And I'll there's a couple things I still need to, I think, plug away at or something, but
no worries.
I just wanted to make sure I wasn't like,
no, you've gotten back up.
Stuff somewhere that I hadn't seen, or because I've been, like I said, it's all starting to blur together at this point.
It does.
I kept saying APT last class. It was the ARP that I was.
ARP, yeah.
Anyway, but yeah, it's just all kind of blurring together at this point. So I just wanted to make sure that I think I'm caught up. Actually,
no, you're doing good.
Except for I'm about a week behind.
No, I can see that you're working. I mean, it's the people who don't log in for 2 weeks. Like I've got people who haven't logged in since the 29th of January still. Right. Not in this class. In other classes, I'm like, hello, where are you at? And then I know as soon as I drop them, I'll get a real nasty email. That happened to me 2 weeks ago. I literally had somebody who disappeared for 2.5 weeks. I emailed them. I let it go for like 6 days before I dropped them. And then like immediately, as soon as I dropped them, like within minutes, what the hell, one email, I'm like,
dude, I reached out to you like for 2 weeks.
You haven't done any work for 2 weeks and you have a 10% in the class. And I emailed you 6 days ago.
Right.
Like, why don't I have email on my phone? I'm like, well, I don't know what to tell you. I'm like, I tell everybody I communicate with email. You should check your email. So,
alrighty, well, I'll let you go eat. I just I wanted to make sure I wasn't missing like a big chunk of something that I wasn't aware
of. Oh no,
of.
you're good. You're doing fine. Yeah, everybody's doing good. This class is this class is nice. I mean, everybody's kind of where they need to be, and things are getting done, and we have questions, and people are showing up for class, so that's good.
I think I'm, like I said, except for the next class, I know I'm a week behind on the Python stuff, but other than that, I think I'm pretty well caught up on everything now, or at least caught up to this week. You know, I mean, I still got to get this week done, but
yep.
Cool.
No worries.
I'll let you go eat.
Yeah, we'll see you in a half hour.
Bye.
Take it easy. Take it easy, everybody.